Hi, my name is Catherine Cameron, and this is my Semester B project. My problem is how to find the perihelion, which is the closest distance between a planet and the Sun in the planet's orbit, and the aphelion, which is the farthest distance, for the Earth and the Sun. This would be easier if the planet's orbit was actually a circle, because then the distances would be the same. But a planet's orbit is actually an ellipse. To find the distance between the Earth and the Sun on any given day, you can use the equation shown on the screen, where d equals the distance between the Earth and the Sun in astronomical units, abbreviated capital A, capital U, and I equals the day of the year. In this case, you'd use 1 for January 1st, 2 for January 2nd, etc., until 365, which is December 31st. There's a lot of data points. 365 to be exact, so I just included the first day of every month to show you here, but you have to use all of the data to find the actual values of the perihelion and the aphelion. So the first method that you use is the data table, which basically means you just look at the data table, all 365 data points, and you find the smallest value and the largest value. So the smallest value will be the perihelion. The smallest value you can find on day 186, which translates to July 5th. The astronomical units are 0.966600304. When you convert it to gigameters, which is the more common metric unit that is used for distance between celestial bodies, you get 144.6013476. For the aphelion, you find it on day 3, which is January 3rd. The astronomical units are 1.033399787, and the gigameters are 154.594408. So the second method is graphing. Basically, you just take those data points and you graph them. When you look at the data table, you can tell that the points go from higher values to lower values back up to higher values, but when you graph it, you can actually see the curve. So here is the graph that I made in Excel. As you can see, it starts at higher astronomical units, goes down in the middle, and goes back up at the end of the year. To find the perihelion, you look for the lowest point on the graph, which you can see is between day 175 and day 200, and is somewhere in between 0.96 and 0.97 astronomical units. To find the aphelion, you look for the highest point on the graph, which you can see is between day 350 of one year and day 25 of the next year. The distance is between 1.03 and 1.04 astronomical units. So here's the breakdown and the conversion into gigameters. For the perihelion, you can see that the gigameters range from 143.6 to 145.1, and the average is around 144.4. But bear in mind that the curve was actually closer to the top of that interval, so it's probably a bit closer to 145.1. For the aphelion, you can see that the gigameters range from 154.1 to 155.6, and the average is 154.8, but bear in mind, again, that there the curve was actually a bit lower, closer to the beginning of that interval, so it's probably closer to 154.1. So the third and final method is to use algebraic strategies. You can do this if you have the value of the semi-major axis and the eccentricity of the orbit. So the eccentricity is how close the orbit is to being a circle. And for the Earth around the Sun, that would be 0.017, which isn't very close to a circle, but it's not too far away either. The semi-major axis is the distance from the center of the orbit, which isn't the Sun. The Sun is one of the foci of the ellipse that the orbit creates. So it's the distance from the center to the outside of the orbit along the major axis. This value is A equals 149.6 gigameters. So to solve this algebraically, you can use the equation E equals C over A, or eccentricity equals the distance from the center to the foci over the semi-major axis. When you insert the values and solve for C, you get 2.5432 gigameters. So to find the perihelion, you can use A minus C. When you insert the values, you get 147.0568 gigameters. For the aphelion, you use A plus C. And when you insert the values, you get that the aphelion equals 152.1432 gigameters. Well, there you have it. Thank you for watching. I hope you enjoyed it as much as I enjoyed making it. Special thanks to the articles scrolling up the screen right now for all the lovely equations and data that I used to make this movie. Thank you.